What up, Algebra 2 dudes? Let's go with talking about exponentials. What is my favorite question that I always ask you to ask me? Why? Exactly. Why should I care? Why does this matter? Exactly. Today, we are going to talk about how these exponential functions completely apply to your lives or will apply to your lives. Sound good? All right. So, check this out. Say that you deposit $1,000 into the bank. And so we got $1,000. All right. This is chapter 6. If you want to print out all the questions and all of that kind of stuff, I'm just going to talk to you about it, and you guys can go straight off of this. You deposit $1,000 into this account, and it's it's exponential 6, I think. No. This is chapter 6. This is expo 6 right here. Yeah. All right. So you deposit $1,000, and it will give you 5% every year. Oh yeah, but I talked about chapter 5. I was done with it. Yeah, we already did chapter 5. It was easy, really. Right? So now we're going to chapter 6, which is super important. I'll tell you what, I'll finish chapter 6 today, and then if you need help, I'll make sure to help out with chapter 5. Is in the video for chapter 5, that's why. Oh, okay. A lot of you guys seem to need help with chapter 5. I was ready to do chapter 6. Okay, fine. I'll do yours. I'll do chapter 5. Let's do that. Chapter 5. And I'll tell you what I'll do. I didn't want to do this M&M thing in chapter 5, so really it's just a matter of doing your homework because that's the only other thing that's in chapter 5. So why don't we just do some problems off your homework? Sound good to you? That way you guys can let me move on to chapter 5. Or chapter 6. Okay, ready? A colony of 125 monkeys in January, or a colony starts off with 125 monkeys in January of 2013. Previously, it has been observed to triple its population every 2 years. How many members would you expect the colony to have in 2015? Okay, so it has 125 monkeys now, or in 2013, and in 2015, which is 2 years after it will triple its population. So I would say just that times 3. Does that make sense? Because it's 2 years after, and they say it triples every 2 years. So there. That's it. I think though that well, I mean, it says that in 2013, this is how many monkeys there are. It triples every 2 years. How many monkeys is in 2015? How long is 2015 after 2013? 2 years. I told you it triples every 2 years. So therefore, wait, let me see something real quick. I just want to make sure I'm not missing the planning. Oh, tomorrow's planning. Okay, good. All right. So therefore, it would just triple. That's all I did. Does that make sense? I mean, I wasn't trying to trick you. There we go. Oh, I see. What you're concerned about is, well, what's the equation? Okay. I see what you're saying. So maybe in year 0, let's make a table. In year 0, you have 125 monkeys. In year 2, you have 375 monkeys. Right? What you're looking for is the table, huh? Or you want to see, well, what is the what's the expression? That's what you guys are freaking out about. Because the next thing it asks you to do is say, well, what about year 113? Or in 2113 of January, how many monkeys are there? If this pattern continues. So essentially, you want to figure out some big number way out here. You know what I mean? And you don't want to, maybe continue this table all the way down. Well, here's what I do. Do you understand how I got this table over here? Because at the beginning, in this year 0, there's 125. In year 2, there's 375. So, from that, you can figure out all of that information. I mean, I'm not even going to go over it because it's that it's, you know how to do this, right? Yeah. C is 125. A is 3, the square root of 3. Whatever that is, 1.41, I think. Cool? All right. And then, yeah, the square root of 3. No, it's the square root of 3. Yeah. And then, from there, you can say, well, what is f of 98? Where did I get 98 from? Or no, not 98. I'm sorry, not 98. What is f of 100? Sorry. Because year 0 was 2013, and they're asking for 2113, so it's just 100 years later. We cool? And that's all you would do. It's really that simple. All right, let's see. A population of a certain microbe to, I'm doing number 5. The population of certain microtube after T hours of a petri dish is given by this. So here's number 5. P, or 1,000, 2.5 T. This is the population of microbacteria inside of a tube. Cool? So my question is, what's the initial population of the petri dish? Well, that's just that number. We good? And here's my other question is, what is the population 1 hour later? Well, you just plug in T equals 1. So it's 1,000 times 2.5, which is 2,500. There we go. Cool. Yeah, T equals is in hours, because that's what the problem said. Did you guys really need help on this one? I mean, I'm not trying to make you feel dumb or anything. I'm just saying that, like, these were from your homework, right? Oh, okay. All right. This is number 5. And it's saying the population of some microbacteria is, okay, I'm sorry. This is number 5 from the chapter 5 homework from the chapter 5 homework. It's numbered number 5. I don't know what that means in terms of which problem number it is on your thing, because for each part of this thing I give you a new question. So this could be like number 15 or something like that. Yeah, number 15 on the homework, you guys. All right, good. So what is your initial population? Your initial population is just this number. I think more mathematically, the way I like thinking about that is if t equals 0, then that gives you your initial number. But 2.5 to the 0 power is just 1, so it's really just that number I boxed. Cool? Do we have to turn in homework, or do we do it just for extra help? No, you have to turn in homework. Does Mr. Dalday do a lot of it for you folks in the class? Yeah, he does. So does that mean I should attend class? Absolutely. Oh yeah, quizzes are like my homework. No, don't worry about it. All right, where does the 2.5 in the problem come from? That was, I don't know, that was the way they stated it in the problem. They gave me a 2.5 right here. So, I don't know, I plugged in whatever number they told me. What does it mean? It means that every year your population is increasing by 250%. So not quite tripling every year, doubling and a half every year. Does that make sense? If I were to write 2.5 in terms of a percentage, remember, converting from a 2.5 number version converted to percentage version basically means take this decimal, kick him over 2 times to the right side. Does that make sense to you? And yes, Lucas, anything to the 0 power is equal to 1. All right. Can I move on to chapter 6? I don't have a lot of time, and I always get burned through these things. I'll tell you what. Open up chapter 6, and I'm going to just start giving you the answers as quickly as I can. I need the video. What video are you talking about? Oh, you're talking about the archives from last week, Wednesday and Friday? Oh, okay. Yeah, I will upload those. I already have them uploaded. I just haven't put them up on our site yet. I'll do that as soon as class finishes. Cool? I wanted to wait to the end of the day so that way I could upload today's video and then just give you all 3 of them. But I'll make sure that last week's archives are up and running. And I'll do that soon. That way it doesn't cause a revolt. All right. So, how does this apply to my life? Why the heck should I care? And this is why I'm so excited to get to chapter 6, because I'm all about relevance. To me, it's so important that math is relevant to you. That's why it's my favorite question. So I'm excited to talk about this stuff because it is important to you. All right, so check this out. You put in $1,000 into your bank. They give you 5% more money annually, okay? 5% annually. What does the word annually mean? Alice, you can answer, by the way. Oh, every year. Good. They already beat you to it.
Oh,
all right.
Okay.
So annually means every year. So I got a question. After year 1, let's go years. And we'll go interest and we'll go total money. All right. So after, I'm going to put a 0 here. The interest is 5%, but it doesn't matter what this, oh no. The interest is 0 because you haven't given it any money. How much money do you have in your account? $1,000. Cool? All right. Now here's my first question. After 1 year, how much interest did you make? Well, all you do is you take 1,000, multiply it by 0.05, so, and you get 50. You made $50. So, how much money is in your total account? 1,050. Are we cool? Now, after 2 years, so this is, in year 1, you made $50. In year 2, at 5% interest, how much money did you make? Sophia says $2,000. No, that's not right. Kaid says $52.50. That's interesting. That's interesting. Why did you make $50 here, and in this one, you made $52.50? Ah, there we go. There we go. Because you weren't working off of just $1,000 anymore. You're working off of $1,050. You have just a little bit more that you are investing into there. Right? Right, exactly. We're not talking about 5% of 1,000. We're talking about 5% of 1,050. We cool? So, how much money do you have in there? 112.5. Right? No, wait. Is it 112.5? Oh, I'm sorry. You're right. 102.5. $1,102.50. Are we cool? All right, let's do 3 years. You want to take 5% of this. So you take this number right here and multiply them by 0.05. Got it? You multiply that by 0.05, and you end up getting 55.125. Is that right? Yeah, that's right. So then you can keep this process going over and over and over again. Are we cool? I know it takes forever. Let's try this. But do you understand how this money thing works? Are we cool? All right. I'm going to erase this if that's all right. Okay. Turn to the next page. By the way, I'm curious to know, Bradley, you got a new BMW, right? I know Bradley's going to respond quick because he's like, yes, I did. I'm so amazing. BMW sent me pictures and everything. Did you take out a loan for that, or did you just straight up cash that thing? No loan? Man, you're a baller. Just straight up cash that. Okay, fine. Then this doesn't apply to you because you don't have any interest to deal with. All right? But I'm just saying. I'm just saying. No. I'm sure that Bradley worked very hard to legitimately make the cash that he needs to, raise the money to buy his new BMW. And I don't question it at all. Bradley wants to be a pharmacist here, folks. Not a pharmacist, an anesthesiologist. So, I'm sure he has no affiliation with drugs whatsoever. Actually, this conversation is going in a very bad direction. I'm going to stop now. That's all right with you, and let's just moving on. Okay, so check this out. The reason why I bring this up is just because I was thinking about like how is this going to be applicable to you, and I'm sure that some of you will have to take out a loan where you have compound interest and all of that kind of stuff, or you'll invest your money into a bank account where you have compound interest and that kind of stuff. All right, let's look at something real quick. Okay. I'm going to invest $100, and I like using the number 100 because it's almost like the easiest thing when dealing with percentage. All right, let's do the same exercise, $100 in, and I'm going 6% annually. How much money will I have at the end of 1 year? This is not a trick question. It's actually really easy. $106. Very good. I should put the dollars in. You guys get it? All right. Now I'm going to do something that's a little bit different. All right. What I'm going to do is I'm going to say, well, instead of doing this 6% annually, use your calculators. Take 6 divided by 4. What is 6 divided by 4? 1.5, okay. Instead of doing 6% annually, what I'm going to do is I'm going to invest my $100, and I'm going to do 1.5% quarterly. Do you guys get it? I'm going to do 1.5% quarterly because I'm going to suggest to you that that's almost the same as doing 6% annually, right? Because if I do 6% one time versus doing 1.5%, but I do it 4 times in that same year, let's say we give both of these accounts 1 full year to make as much money as we want or whatever. Isn't this the same kind of deal? Right? And Kai and Lucas and Bradley is saying no, but Sophia is saying that makes sense. Here's my question. Why are you guys saying no? Is it because Mr. Dalde is usually a jerk and I always try to trick you? Or is it because you guys have some kind of insight that you guys are thinking of? Yeah. No, Jenna's right. 1.5 or 1.5 times 4 is 6, and that's absolutely true. And what I mean by quarterly is I'm going to, instead of doing it once in every year, I'm going to do it 4 times in a year. But Lucas is onto something. What Lucas is saying is, yeah, okay, but this thing is going to act just like that previous problem. He's going to say, so what you mean by quarterly is at the end of the first 3 months, you're going to evaluate this thing. And then at the end of the next 3 months, you're going to evaluate this thing. But the second 3 months is not going to be based off of your initial amount of money you put in. It's going to be based off of however much money you have after you evaluate it on your first 3 months. Did I make sense there? Which is ever so slightly bigger than your initial amount of money that you put in. So therefore, your second amount of money will be even more than it probably should be. Here, let me make that table again for you. This would be year 0. I put 0 amount of money is my interest, and here is my total dollars. This is years. All right. So So I got $100 to begin with. Cool? After, I don't want to put years, I'm going to put M, as in months. Months. Sound good? So after 3 months, which is a quarter of a year, I made $1.50. And that gives me $101.5 in my account. Cool? After 4 months, or after 6 months, which is half the year, the next 3 months after that, I made 1.5225, which gives me 103.0225. Look, I made more interest because I'm not basing my interest off of 100, I'm basing my interest off of 101.5. Ever so small, slightly, whatever, bigger. We cool? All right. And then at month 9, which is 3/4 of a year, I made $1.54, which gives me 104.5678,375. All right, and then at 12 months, which is the full year, I made an extra 1.5685. And how did I get that? I just multiplied this number by 0.015, and I made 106.14. It's actually 136, whatever. But I'm going to round it off to 4 because we're talking about cents here. So, wait. Well, I'm doing this to make a point. Okay? You make more money. Right? Like you get more money. You get a full, wait for it, 14 cents more if you were to do it quarterly than if you were to do it annually. Cool? And I think if I wanted to make a formula instead of some ugly table here, if I wanted to make a formula, what I would say is I went like this. I did 100, which is how much I initially invested, times, I love your logic here, ready? It's 1 plus 6, or 0.06 divided by 4 to the 4th power. Right? Like, where did I get that 1.5 from? I did 0.0, or where did I get that 1.5%, which is then also known as 0.015? Where did I get that from? I took the 6% and I divided it by 4. That's where that comes from. Cool? So really, it's kind of what you're saying. It's actually this. It's 100 times 1.015 to the 4th power. Are we cool? In fact, if you were to use your calculator and plug it into your calculator, what is 1.015 to the 4th power? Multiply that by 100. What do you get? Where does the 4th power come from? The 4th power comes from evaluating it 4 times in that year. And we're assuming this goes over 1 year. All right. Kai did the calculation. You actually plugged this into your calculator, Kai? And you got, what, 1.0613? Oh, okay, yeah, you're right. Times 100. So it's 103 points, or 106.136. It's the same numbers right here. So instead of making this crazy table, I could have just used this formula. Does that make sense? All right. This is really confusing, Bradley says. And you don't need to do this every time you do your homework. All right? I'm going to tell you now. I have, believe it or not, Mr. Dalday actually has a reason for the approach and the direction I take. And my reason is this. This table is very annoying. But it's not hard, right? It makes sense. Okay, it's very annoying. It's not hard. It makes sense. Now, this formula has to be correct because I got the same number as the table. All right? That validates what I wrote down here. So what I'm going to do for you now is I'm going to, all right, Sophia doesn't like, you don't like this formula right here? You don't understand where that comes from? Okay. I'll tell you what. Let me explain all the pieces to this, because this is what you guys are all pissed off about, and this is what I really want to get to. All right. The word quarterly means 4. That's why, in order to get the, instead of doing the 1.06, I ended up doing 1.015 because I took that 6%, 0.06, and I divided it by 4. You guys get it? In the business world and finance world and economics, when we say a quarter, we're just talking about 3 months. Okay? So that's why this is 0.06 divided by 4. Are we cool with that? All right. Bradley asked, where does this 1 come from? Okay? And I think I saw earlier in the comments something where when I had this expression up, Bradley wrote down, oh, so the ratio, the A, you know, that A ratio that we have been talking about in the past exponents, oh, so that's equal to 0.06, right? That's what Bradley said. And immediately, half of you jumped on him and said, no, it's not 0.06, it's 1.06. Because you need to account for 100% of it plus the additional 0.06. Does that make sense? All right. So that's where that 1 comes from. Are we cool with that? You understand where this big 1? Because this is 100% plus whatever fractional percentage you have. Okay? And then this is in 1 year. And I was specifically looking at 1 year, so I put to the 4th power because we evaluated this thing quarterly, which means we evaluated it 4 times over that 1 year. Are we cool? And the 100 comes from my principal investment. That's how much money I put in to begin with. No, your homework is not going to suck. I'm going to show you the magic formula right now. You ready for it? The magic formula for compound interest is this. A of t is equal to P times 1 plus I over N to the NT. Write that down. All right, Sophia's all impatient. She's like, why did you give us all of this stupid backstory when all you could have done is just write down that equation, right? Remember, what is my biggest pet peeve? What is something I cannot stand? I can't stand math teachers saying, here, memorize this formula. Here, it's right here. Take it. Right? I can't. It upsets me when people just say, use this formula from now on. Look, you understand each piece of this formula. The P is the principal. That's how many. That's how much money you put in to begin with. The 1 is Bradley's number. That's the 100% to begin with. The I is the amount of interest you want to charge per year. Okay? The T is the number of years you're going to put money in, or you're going to let this money sit. The N, this is where it gets not tricky, but the N is the number of times you evaluate that interest in the year. So if I say we're going to evaluate this thing quarterly, then N equals 4. If I say we're going to evaluate this thing biannually, the number is what? We're going to evaluate this is 2, because that means I'm going to evaluate it once or after 6 months biannually. You guys get it? If I say we're going to evaluate this thing monthly, what is N equal to? 12. Very good. Because if I say we're going to do it monthly, then we're going to be doing it 12 times in the year. So you put a 12 here and a 12 there. If I said that we're going to be evaluating this thing daily, what is N equal to? $365. Very good. So I think that this is how easy your homework is going to be. Your homework is literally going to be, I'm going to give you the number for P, I'm going to give you I, I'm going to give you N, and I'm going to give you T, and all you have to do is plug it into your calculator and put in your answer. All right, Sophia, I'll consider that. I'll consider throwing up an equation out of my pocket and saying, here's the formula I want you to understand. Let's explore all the different pieces to it. I think that Bradley's asking something about this NT right here, N times T. All right. What that NT is if I wanted to do this thing over 2 years, okay? If I wanted to put my money in that is evaluated quarterly at 1.5% quarterly for 2 years, I would basically take this thing and square the whole darn thing. Right? Actually, no, I'm sorry. Not square the whole darn thing. Square this part of the thing right here. Square that part there. Which means I multiply the exponents, so it's really, I'm just raising it to the power of 8. Because if you think about it, if you're doing this thing over 2 years and you're compounding quarterly, how many times is the banker going to be looking at evaluating this thing? Well, if it's evaluated 4 times in a year and you do it over 2 years, it's going to be done 8 times. Make sense to you? What if it doesn't give you the amount of money like in our homework? Okay, I got a good suggestion for that. Then what I would do is, what I think your homework is asking is, what happens if I just tell you compare 12% compounded annually versus like 3% compounded monthly or something like that, or 11% compounded. Then I would use exactly Bradley's suggestion. I would say, well, what is P? Let's let P equal 1 or 100. Let's let it equal 100. And they say, well, if I invested $100, which one would I make more money on? We cool? I got to get started with physics right now, so I apologize. I got to go. But what's your brains on that? How's your thoughts? This is not hard. On Wednesday, I'm going to go deeper into this thing. Yes, I will upload this archive at 3 o'clock today. Okay? All right. I'm going to upload last week's archives at 3 o'clock. I'm going to upload today's archive tomorrow morning. Sound good? All right. I'll see you folks later. Goodbye. All right. Let's see.